Alright, hey, how's it going? Um, Hope you are well. We are working on compound inequalities. That's where you've got more than one inequality that's joined together with the words and, or, or. For example, um, 2x plus 80 billion is less than 5, and 5x plus 12 is greater than 7. That would be two inequality statements jammed together, joined together by the word and. Um, and let's talk about how to graph these things, to graph the solutions to these things. So I'm starting with a solution here. Say you had two inequalities that you had to solve. You got it down to x is greater than 3 and x is less than or equal to 9. How would you graph that? How would you visualize those solutions? Um, here's the same solution written in a couple different ways, by the way. This is in set builder notation that says x is a real number such that 3 is less than x, which is less than or equal to 9. You know, basically x is between 3 and 9, including 9. And here's interval notation. The solution set is from 3 to 9. This um, this thing is saying I'm not including 3. This thing is saying I am including 9. So 9 and anything less than 9 would count. Um, so how? So, but let's graph this. This is all pretty abstract, right? So let's make a number line. Um, Here's a number line. It goes to positive infinity in that direction, negative infinity in that direction. It's a good metaphor for what numbers are and how they relate to each other. Um, so let's put our two key points on here. 3 and 9. 3 is less than 9, so I'm going to put it over here to the left of 9. 9 is greater than 3, so I'm going to put it over here to the right of 3. Okay, so um, the solution to an AND type problem will be the intersection or the overlapping of the two inequalities that are being joined by AND. So what I would do is actually kind of lightly draw out each one individually and then see where they overlap, if anywhere. There could be no solution. See where they overlap, and then make that your real answer. So let's just look at these individually. X is greater than 3. Okay, so I'm gonna start with 3. Do I fill in the circle or not? No, I don't, because it's greater than 3. It doesn't include 3. So I'm just going to draw an open circle like that, which is saying anything up to 3, two, what 3.00000000002 would count, but not 3. Okay, so x is greater than 3, so I would draw, and let me, because I can do this in this program, I'm going to make that a dotted line to show that this is sort of tentative right now. We're just sketching this out to see where these two overlap, and then our real solution will be, where they overlap. So okay, so that's the first part. X is greater than 3. Now what about x is less than or equal to 9? So I am going to. So we start with 9. Do I fill that in? Yeah, because it's less than or equal to 9, so I have to include 9 in there. Maybe we should do this in a different color. Okay. And so it's less than or equal to 9, so this part of it is going to go this way. It's less than or equal to 9. Okay. So this is an AND type problem. So the solution will be where these things overlap, because both of these conditions have to be true. So my real solution will be right here. So it'll be like, okay, so let me make this solid, because this is the real deal now. And what color should we do this? What would be visible here? Let's make this purple. And then I would draw up to here, and then I'd fill in a dot right there. that's pretty sloppy. So let me redo this over on the side now that yeah. So number line, here's 3, here's 9. Open circle here, everything in between, closed circle there. Should be 9. I don't know if you use this kind of notation at your school. You can also, that's like interval notation. You could do it like this. Instead of open circle, closed circle, you can do that curve and then the bracket like that. Like these things instead. Whatever way. I mean, this to me is more intuitive, I guess. All right. So let's try this again. But first, let's solve the compound inequality to get to the point where we have a solution like this, and then we'll graph it. So 2/3 x is less than or equal to 12, and negative 1/3 x is less than negative 9. So let's solve these two. So you deal with them separately first. I'm just going to rewrite this. 2/3. Kind of like this purple. Maybe it's a little hard to see against the blue though. So let me just go to my standard orange. Okay, so to get x by itself, it's being multiplied by 2/3, so I should divide by 2/3 to get that away. And dividing by 2/3 is the same as multiplying by 3/2. I just flip it over and multiply. So I'm going to multiply both sides by 3/2. So x, 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1, 1 times x is just x. That's why that works. So x is less than or equal to 12 times 3 over 2, so 12 times 3 is 36. Divide that by 2, that's 18. So here's one part of it. X is less than or equal to 18. And you know what? I'm going to change the sign because I think something, yeah. Let's make this a positive 9. Okay. I think, is that right? Yeah. Let's try it with positive 9. Okay. I just want to give you an example. I think this would work out to where there would actually be no solution. But let me actually do it where there is a solution. Just a little side note. If you're graphing two things and it's like one goes this way and one goes this way and it's an anti-problem, then there's no solution because there's no place where these two overlap. Okay, so the answer could be no solution, which you can symbolize with that, or you could say just there is no solution. There is no solution. Yeah. Okay, but let's keep going. Let's say that's positive 9 actually. So negative 1/3 x. No, I do want no. Because we're gonna flip the sign. No, yeah, that's right. I don't know. Maybe I thought about this. Let's make it negative x, negative 9, and see what happens. Okay. So no. Let's make that positive 9. Sorry, I keep going back and forth. Okay. Negative 1/3 x is less than positive 9. Okay. So I want to solve for x here. So I'm going to multiply by negative 3 over 1. Just multiply the reciprocal. Multiply by negative 3 over 1. So I am going to, first of all, I'm multiplying or dividing by a negative number, so I need to flip the sign. So here, all we have left is x. So 9 times negative 3 over 1 is negative 27. Yeah, that's what I wanted. So the solution is x is less than or equal to 18 and x is greater than negative 27. Okay, but let's graph it. So here's my number line. Now let's look at these key points. I've got 18 and negative 27, so let's, smaller number goes to the left, 18. You don't need to mark every little tick mark or whatever. It doesn't matter. Okay, so x is greater than negative 27. So let's do our kind of so this is what just x is greater than negative 27 would look like just by itself. And then x is less than or equal to 18. So 18 counts, so I'm going to fill that in. And it's less than or equal to 18, so I'd go this way. So the real overlap would be here. So this is and, so I need to know where both of these things are true. So my real answer would be, make that a solid line. Let's make that green, I guess. Would be, and let's make it thicker. Green would be here, the region where both those graphs overlap. Now, as you practice this, and you don't need to do the first lines first. You can just visualize it. That's fine. But yeah, to me this helps to see where each inequality individually would be graphed, and then I can see it's clearer to me where they overlap. So hence, the intersection, or where both conditions would be true, that this and this would be true.